All right, folks, we're going to try and get started here. We got a few of you viewing right now. So there's a couple ways you can contact me with this. One is to use Edsby. I do have the Edsby messages up, and I'll be checking those regularly throughout. Another way is email. If you want to send me an email, you can do that as well. And the third way is through the YouTube chat. You do have to have a YouTube account to use the chat portion. So even if you want to just make a fake account or whatever, just so you can send messages. If you have questions along the way, make sure you're asking. Otherwise, like I said, I'm going to try and do some just quick overview of section 3.1 of the volume of Prisms and Cylinders. And then, again, if you guys have some questions, make sure you ask if there's a specific question on the out of the textbook that you want to take a look at. We can do that. Take a look at that. So again, Edsby messages through the live chat or through email, all ways that you can get a hold of me during the live session. We're going to try and stick to around half an hour at max, and then we'll see how it goes. Okay, make sure my camera's working. All right, so let's get started. We're talking about the volume of prisms and cylinders. So some key things again, just to reiterate from the video lesson. Do make sure you're watching the videos on YouTube. They'll go over the kind of lesson that I'd be standing in front of the class doing with you guys on the overhead, and get you kind of set up for it. This first little section we're doing just pretty straightforward, only a couple sections to it. Prisms, cylinders, then there'll be cones and spheres afterwards, and that's about it. And that'll kind of cover all our perimeter area volume section of the course. Don't feel as well that you need to keep up with everything. I know some people are on different time schedules. There's no due date specifically. I'm just kind of doing these live sessions to answer some questions along the way, if you guys have them. But they'll be available to watch afterwards too. So if you miss one, don't worry about it. No sweat on that. But just taking a quick look at volume with the prisms and cylinders. My writing is terrible right now. So prism cylinders, they're both the same thing. They are an elongated shape. So you take a base shape like a rectangle, and all you're doing is stretching that out. You're actually like stacking them on. If you watch the video, I believe I pulled out some poker chips and kind of stacked them up to show like a cylinder being made by stacking things together. If you look at the pages in your textbook, and I'll kind of see if I can do that here. So I got my textbook here, and if we take a look, each of these pages is a rectangle, and so each page, focusing very well, but each page gets stacked together, and that adds the depth to this. So when we're working with volume, we're looking at taking an area and just stacking the whole bunch of areas together so that we have the area of the base, so the length times the width of our rectangle here, and then the distance that we travel when we're stacking up all these little bits and pieces of them. So the height is what we usually call that with a rectangular base prism. Height, depth, I'll use those words interchangeably because depending on the situation, it could change. It doesn't actually matter what you call these. This doesn't have to be length, width, and height. This could be the height here. This could be the width and the depth. As long as you're using 3 different dimensions, volume is looking at things in 3 dimensions, meaning there's actually 3 measurements. So that's the general concept of it, and then when we go to use it, we're just filling in those values. So if we have a box that is 5 centimeters by 6 centimeters by I don't know, 4 centimeters, volume is, and so we can get a box 5 by 6 by 4. And now another way you write by, when we're talking about dimensions, if you go to the lumberyard, sometimes you'll see, 2 by 4 by 8 or whatnot written like this, 5 by 6 by 4. So we actually have the length, the width, and the height. And the way we use by, and we often convert that into mathematical language, is that we use an X. And so we often see that at the lumber mill, things like that. So our volume is the length times the width times the height of that box. And I never explicitly said that any one of these was length, width, or height, so it doesn't matter. It's your choice as to which one's which, as long as you're multiplying those 3 dimensions out. And so we actually multiply those out. 5 times 6 is going to be 30, and 30 times 4, that's going to be 120, and in this case, centimeters cubed. So the volume is 120 centimeters cubed. So that's all we're doing with the volume here, is we're just multiplying 3 dimensions together. And so that works with the area of any rectangular prism. Even if it's a square base, same idea. In the case of a triangle, as the base, and I never like the way I draw these, but there's a triangular base prism. And again, we look at that triangle, and then we're stacking up a whole bunch of triangles here. So it's like a big stack of triangles. Oops, sorry, put that on the screen. So we're stacking a whole bunch of triangles. So we have our base. We have a height on our normal portion of the triangle. So that's our normal area. And so the area of that triangle is 1/2 the base times the height. And then I usually use the word depth for the length here. But we could use length. We just generally don't want to mix it up with height. So we use depth. But as long as, again, we're multiplying 1, 2, 3 measurements. The difference here between the prism, rectangular base prism, and this one is that we just have a 1/2 because we're calculating the area of the triangle at first. The one that does kind of throw a bit of a loop in terms of this, we need 3 dimensions to multiply together, would be the cylinder. The cylinder is a circular prism that has circles stacked up. Again, this could be like my poker chips all stacked up. So you're just stacking something up. And so we have the area of our circle here. And again, we have a radius, which is halfway across. So the volume of this is pi r squared, which is the area of the circle, times the height of this whole thing. And now, in the previous 2 here, if I pop them up, I had said, length times width times height. Multiply 3 things. Multiply our 3 different dimensions here, base, width, and height. Here we only have 2 dimensions, but remember, r squared actually means r times r. So technically, we are doing pi times r times h. That's our r squared. So we're actually multiplying 1, 2, 3 dimensions. And that's giving us our 3D formula for this. Ethan's got to quit dropping his phone because that sounds like a regular annoyance in a class. So I'm trying to keep this on screen and things like that too. I noticed that comment. There is a slight difference from what I see on my screen as to what's being broadcast sometimes. So if you can't quite see something, let me know. I got a weird camera setup here, and some things disappear, or I think they're on the screen and they're not on the screen. So let me know if you can't see something right away. The other big thing to note out of this section is just that concept of capacity versus volume. If you were to look up a Greek, another Greek term here, but Archimedes is a guy from ancient Greece, and he had this problem about finding out whether a crown was made of gold or if it was fake or whatnot. Anyways, he used this concept called displacement. And so what that is, if you ever fill up a pot of water and then you drop in, you're going to boil some potatoes, you drop in your potatoes, and then the pot was already full, you add the potatoes and the water that spills out. That is because the volume of those potatoes, the space they took up, is the water that spilt out. So that actual amount of water that spilt out is just like the volume. So if you actually measure the amount of water that was spilt out, that is the volume that we're calculating. The capacity would be actually how much water we poured into that pot. So that's the difference in terms of volume and capacity. And so the capacity, there's a couple relationships that we do have that are important to work with. 1 liter, so we usually measure capacity in liters. We're going to try to stick to centimeters, meters, and liters just for convenience sake with this unit here for the most part. So 1 liter is 1,000 cubic centimeters. It's actually, I'll try and draw it here for you. I would draw a 1 centimeter, or no, not 1 centimeter, but centimeter, 10 millimeters. Nice and straight and pretty. Okay, I kind of failed at that last bit there, but this cube here, this 10 centimeters by 10 centimeters by 10 centimeters, that makes up a liter. So thinking of centicubes, you divided these up into a whole bunch of little bits. If you had 1,000 centicubes, little colored cubes we played with, that you may have played with in previous classes, that is the volume of 1 liter. The other conversion is that 1,000 liters equals 1 cubic meter. And you may remember on the board a couple times I drew that big meter square, and then we actually, if you stick that meter stick out from that, you step 1 meter out from that meter squared, that's a cubic meter. That's 1,000,000 of those centicubes. So 1,000 liters is 1 meter squared. 1,000 cubic centimeters is 1 liter. So important to not mix those up when you're doing calculations. It's 1,000 to 1 centimeters to liters, but it's 1 to 1,000 when we're talking about meters to liters. Again, this is liters portion, that's our volume, or sorry, our capacity, how much will fit inside something. That's our volume in the meters and centimeters squared, or cubed, how much it'll actually take up. Beyond that, if anybody's tried some of the questions and has any specific questions in regard to the stuff in the textbook copies that I gave you that are on the in the content section of Edsby, let me know. Otherwise, I'm just going to take a look at an example question here. That'll probably wrap us up for today. So if there's any questions, let me know. Otherwise, I'm going to get started here in a moment. I'm just delaying because there is about I'm not sure what the actual delay is between me and you guys actually hearing me, but I do know there is a delay on the live stream here. Okay. while I'm waiting to see if anybody has any questions, let's do question number 5. Question number 5 from the 3.1 worksheet there. So question number 5 has us calculate the volume of a tank, and I'll actually flip over here. So I can see it. A copy of those worksheets. So question number 5 right here. Calculate the volume of this tank. What do you think would provide a greater increase in volume? A tank with double the diameter or a tank with double the height? Draw each new tank and label the dimensions. Calculate the volume of each new tank drawn in part B, and then compare the volume measures to your prediction in part B. Was your prediction correct? So let's flip back over here to the note. So we were calculating the volume of a tank. It was a, trying to draw a circle here. Not the best ellipse drawing skills, but I think you guys get the idea. We have a 2-meter tank and then a diameter of 2 meters. So 2 by 2 kind of dimensions on that tank. And oh, what do we got here? Any messages? See some messages. Oh, it was. Aiden says it was his birthday yesterday. He's now 15. Happy belated birthday there, Aiden. So let's finish up this question here. So the volume of a cylinder is pi r squared h. We have a slight problem in that we don't have the radius. We have the diameter. So the diameter is 2. To get the radius, we have to divide that by 2. So volume equals pi times, and actually let's switch that pi out. Again, if you have a pi button on your calculator, feel free to use it, but otherwise 3.14 times 1 squared, I'm going to put that 1 in brackets, times the height of 2. Multiply all those out, and 1 squared is going to give us 1. 3.14 times 1 is 1. 2 times 3.14 is going to give us 6.28 meters cubed. So that there is the volume of this tank. So that was the part A to that question. And then if we flip over to the question again, the next part says, what do you think would provide a greater increase in volume? Tank with double the diameter or a tank with double the height? I'm going to give you guys a few seconds. If you can reply, what do you think it's going to be? Take your estimate. If you haven't done this question yet, or you don't remember doing it, what do you think it's going to be bigger? The doubling of the height or the doubling of the diameter? And this is actually a useful little thing. I've seen this in a couple of little trick videos that you can do with your friends to kind of win bets amongst your friends. So when you're out for dinner and you get yourself a glass, there's a little trick about what do you think is bigger? If I wrap something around the top of the glass, like a napkin, so you take a napkin and wrap the napkin around the top of the glass, or stretch it down the side of the glass. Which is bigger? Length of around the glass, circumference bigger than the height. That kind of thing. That's a common little bar trick, and you can test it out and then see if you can fool your friends with it. All right, so I got a couple replies here. So people are guessing the same. All right, so let's. So we're thinking that doubling the height and doubling the diameter are going to be the same. So let's actually calculate both of those. So double the diameter first. So if I double the diameter, that means the diameter becomes 4 and the radius is now 2. So volume equals 3.14 times 2 squared times 2. 2 squared is 4. And then we have 3.14 times 4 times 2. And that's going to give us 25.12. And rounding to the 1 decimal place, 25.1 meters cubed. Now if we double the radius, or double the height, volume equals 3.14 times 1 squared, because the radius stays the same, times doubling the height to 4. We have 3.14 times 1 times 4, and we're going to get 12.56, or rounding that, 12.6 meters cubed. So, which one's bigger? Doubling the height. Not the right answer. The diameter doubling because of this here. So when we double the diameter, what you actually do is you're multiplying it. You double something, you're multiplying it by 2. And when you double something by 2, oh, sorry. There we go. Better, guys? So here's my calculations. So what happened here when we doubled this diameter is that the radius squared doubled. So when we have r squared h, those are the things that we were doubling. Well, when you double this, you also square it. So you're actually doubling 2 r's. So remember we wrote earlier the volume equals pi times r times h. So you're only changing this 1h here, but you're changing both of the r's. So you're actually doing it twice. You're making that change twice because it's squared. So a little tricky situation there. But again, you're just estimating there, taking an educated guess in part B, and then you're actually calculating it. And that's one of the great things is we can actually use these formulas and calculate the actual answers and model these situations and actually see what is the correct answer. So the last part there, D had just said to compare your predictions. Well, a couple of our predictions I see that they weren't quite correct, but that's okay. Again, okay, because we're just doing predictions. So from here, again, just a little bit of practice is the idea of what we're doing here. Trying to just reiterate some of the key concepts from the lesson, take up anything that you may have a question about. If you take a look at the EDSB page there, again, in that content section in the bottom left side, there'll be some updated stuff. I put up some stuff this morning on just a review of chapters 1 to 3. So our volume, perimeter, area, and just some basic number sense. So you guys have that that you can take a look at as well. If you have questions outside of these live streams, or if you can't make the live stream, you can email me. You can send me a message on EDSB. And I also said in the there was a little write-up that I put in one of the first posts on the feed of how to sign up with Remind. Remind, you can use text or email based to get messages. It's actually completely anonymous, so that the number that I've provided there is not my number. It's a number Remind setup, and it just allows us to communicate again through text or email. That's really quick. And then if I'm not at my computer, I'm usually have my phone around, and I can check that, or if I'm out for a walk or something, I can even answer you when I'm there, and doing that. So that's another way to keep in touch. So if you have questions outside of these videos, feel free to ask them along the way. I'll keep posting stuff. Probably looking at early next week for the next live stream. I'll put a little thing up on Edsby as well, that you can kind of post any comments or thoughts or ideas of how to make it better, or things you like, didn't like, what you'd like to see, kind of thing. So I'll put that up in a little bit. Also, there'll be a copy of the live stream available for you to watch. Again, if you want to take a look at anything. All right, so that's about it. We'll wrap this up, and hope you guys all have a good day.